I'm Costanza Borghi. I'm a first-year PhD student at the University of Florence. And today I'm going to show you a preliminary research about disturbances in forests in Italy. Actually, we monitored 35 years of Italian forest disturbances using Landsat time series. As everybody knows, natural disturbances, especially in forests, are an actual and a big problem, not because forests cannot overcome these problems, but the anthropogenic intensification of stressors express itself mostly due to climate change. So forests are particularly vulnerability to these rapid changes. So we would like to assess how these changes change over the years. So the aim of the study is actually identifying the incidence of particularly large disturbance events in Italian forests and actually evaluating how this pattern varied over time. So first of all, we use the forest mask of Italy to focus on actually the forest as reported in D'Amico et al. Paper, which is the current best wall-to-wall forest mask available in Italy. And against the NFI data, it only has a standard error of 0.3%. So it's a very good forest mask. And it's a Boolean mask, which are forest or non-forest pixels, as you can see in the photo. Then we use the Landsat time series, which cover, in our case, 35 years for 1985 to 2019, and with a spatial resolution of 30 meters. At this time series imagery, we applied the best available pixel, which is an app or developed in Google Earth Engine environment, which produced cloud-free composite calculation and very easy to implement. And then on these images, we applied the 3i3D algorithm, which is an unsupervised algorithm also implemented in Google Earth Engine by Francini and Altri in 2021, which uses 3 vegetation and 3-dimension indices to produce a map with every pixel as a value of disturbed or not disturbed. So we obtained this map of forest disturbances at 30 meters spatial resolution as the Landsat time imagery, but we have actually 35 maps, one for each year of the search. Then we calculated the area of forest disturbances expressed in hectares at 3 levels: provincial, regional, and national. The standard disturbed area, which is the average of the disturbed areas registered by the 3i3D algorithm direct map in the 35 years, we obtained this data only at provincial level. Then we identify the so-called extreme events, which are the events 80% greater than the standard disturbed area. About the 3i3D map, we assessed its performance using the reference dataset. We used 9 squared areas of 15 kilometers wide, randomly sampled around Italy, and we photo-interpreted these areas using high-resolution multi-temporal orthophoto and satellite images. Then, in this map, in this dataset, we calculated confusion matrix, assessing the number of true positives, true negatives, false positive, and false negatives. Here are the results. As you can see in the map on the left, we have a very specific concentration or extreme events occurred over the first 10 years of study period, which are 1985 to 1995. So 46% of the events are concentrated in this 10-year span. And the greatest events were detected in 1991 and 2016. And actually, as I will show you later, these are particularly interesting because actually, as I said, in these years, we have 2 main events. In 1991, we have an exceptionally cold weather, while in 2016, on the other side, we have a record-breaking drought, which oppressed Italy. The total number of extreme events over the 35-year span was 14 and 72. The lowest years were 2000 and 2010, while the highest, as I said before, 1991 and 1985, another year of exceptionally cold weather with 28 extreme events each. Then we assess the disturbance detection algorithm performance, and we make a comparison between the map, the disturbance map made by Samson Seidel, and the map provided by 3i3D algorithm. This, as you can see in the GIF, is one of the 9 square areas, as I said before, and this particular area is near Rome. As you can see in the map, the 3i3D algorithm detects a lot of pixels more than the Samson Seidel one. So actually, the 3i3D algorithm is better both in omission and in commission errors less than the Samson Seidel disturbance map. So it's a very good application for disturbance monitoring. In conclusion, we can say that with this approach, we can assess more disturbances occurring on the same pixel. In comparison, for example, as I said, Samson Seidel 1 identified only the pixel with the largest disturbance in terms of magnitude, while, for example, the global forest change by Hansen identified just the pixel with the last disturbance occurred in that space. So this permits to have a lot of more stratification of disturbances and information in the same pixel, having 35 maps. As you can see in the previous slide, extreme events, as we said, seems to decreasing over time and not increasing like maybe some authors like Ceccherini and altri express, especially due to utilization. Then we have the comparison between drought and freezing events. As we can see, in 85 and 91, we have 2 big freezing events actually in Italy, while thanks or maybe due to climate change, maybe these events in the Mediterranean area will not so frequent as drought, which is the main problem maybe in the future. And thanks to these analysis, we could evaluate also how forest responds to stress induced by climate, for example. And also another pro of the 3i3D algorithm is actually very tunable using the Google Earth engine, and also on GitHub you can find the application, and it is very, very easy to tune and apply to all your search. For future development, we are actually working on the development of this research, and we would like to correctly identify the disturbance drivers, and this can permit to assess how the disturbance driver pattern changes over year, and not just there is a disturbance or not disturbance. For this, we are working on a pixel spatial grid for the identification, and we are also using rare literature analysis about extreme events reported maybe not in scientific papers, and obviously experts know how about this particular event. That's all, and I thank you for your attention, and